X or solve for N or something like that, but you're subbing and you're solving. Okay, so if you can substitute using your calculator and using just like your brain, and if you can solve an equation, for the most part, you are fine with finance. I think where finance gets a bit tricky is because we often have to wade through the story. So like you can see in the example, it's a lot of writing that we have to get through in order to get to like the crux of the question. And I think this sometimes freaks us out in math because math we're used to numbers, not words. And so we have to be able to get past that and actually get into what the question is asking. So like I said, what we deal with very much in grade 12 is this idea of an annuity. Now, an annuity is basically, at a very basic level, equal payments that we make at regular intervals that are affected by interest rates over a period of time. And this is why both investments and loan scenarios are annuities. If you think of like a loan, I'm trying to think, let's say you've bought a car. Okay, you've bought it on loan. You are going to make regular payments. These payments are usually monthly in order to pay off that car. If you have invested money and you are going to contribute or make a contribution to that investment on a regular interval, again, usually monthly, this is an annuity. Okay, so like I said, the payment period or the intervals at which we make payments or make deposits is 9 times out of 10 a monthly interval. It doesn't have to be a monthly interval. It doesn't really change much, but it doesn't have to be. As long as they are equal intervals, we're fine. We have to take into account what effect interest will have on this amount. Obviously, in investments, the hope is that your value or your accrued value is going to increase. If it is a loan, obviously we know that anything you buy on loan has to have interest repaid on it, which means that we end up paying more for whatever item it is we've chosen to buy. And so we need to take that into account. What we're going to chat about today, though, are future value annuities, which deal with, for the most part, saving up for something, retirement annuities, investments, etc., etc. And this is where, like I say, if your scenario talks about saving for the future, putting money away, investing, saving money, we are talking about a future value annuity. If your scenario context says anything about a loan, present value, and we will talk about that a bit more on Wednesday. Right, so as I've already explained, this is your future value annuity formula. That's that boy over there. And I'm just going to explain some of these variables because not all of them are familiar to us. So firstly, F, future value, it's your final amount, for lack of a better descriptor. So kind of like what we had when we had A is equal to P1 plus I to the power N, F and A represent very similar things. It's the final accumulated amount that we are working with. I is obviously your interest rate. And what we need to remember here is that it is a rate. Okay, so that implies a percentage, and we'll talk more about this when we get into our formula in a second. And we need to take into account any compounding periods that may exist. Okay, so I'm just going to put a little star here, compounding periods. If it's compounded quarterly, monthly, semi-annually, whatever, we have to take that into account. So those are two values that we are sort of familiar with. We do understand what they mean. N, also something that we're quite familiar with. This would be the number of payments. I'm again being lazy. Hashtag number of payments. And we know this already from grade 11 when we talk about compounding periods. What's new is this X value, and these are your installments. So if you are making monthly installments, how much are you paying each month? That is X. If you're making quarterly installment, how much are you paying every 3 months? That amount is your installment. So this is your installment amount represented by X. And this is the formula that we're going to use in the next few questions as we go through. Now, there's just two things I want to make quite explicit when using this formula, because this can trip us up a little bit, and I don't want it to trip us up because there's no need for it to be tripping us up. It is all relatively straightforward. We just need to make sure we know what we're doing. So the first thing is that whenever we talk about monthly repayments, we are talking about repetitive payments. So we just need to be mindful of the fact that there are going to be multiple payments that we're needing to take into account in our calculation, because it's not just a once-off payment like we're used to, say, from like grade 10. Another thing we need to take into account is sometimes these installments can happen immediately. And so if it says it is starting immediately, we need to take into account the fact that there is an extra payment. And there are examples like this that we're going to have a look at. And I'll try to explain this a little bit more in a second, but we need to take this into account. So what this means is, let's say, for example, I say, so-and-so has opened up a retirement annuity and they immediately deposit, I don't know, 2,000 Rand. Thereafter, they make monthly deposits of 2,000 Rand. What we need to account is that the monthly payments or monthly installments is the norm, for lack of a better word. That is normal. We know that an annuity means monthly installments or regular installments. But the fact that we chose to immediately deposit an amount means that that first 2,000 Rand is in there for an extra, whatever the period is. So if we are making monthly installments, it's in there for an extra month earning interest. And so we need to essentially consider that as an extra payment that we have made into the account. And we need to take that into account when we now substitute our formula. So this is what I'm saying. Sometimes finance is a bit confusing, because we have to read our questions so carefully to make sure that we are actually taking into account the appropriate in value number of payments, the appropriate compounding period, etc., etc. Hang on. I'm so sorry if you can hear my cat in the background. He's having a bit of a temper tantrum. We're just going to ignore him, because apparently, like teenagers who fight, cats are children as well. Okay, so these are just things to bear in mind, particularly the starting immediately, but I do have examples like this where I'm going to explain this concept a little bit more with an example, and we'll hopefully see what the wording is and kind of keep that in our brain somewhere, that we have to then add an extra value to our n. All right, so I'm just going to wait in case anyone does want to screenshot this, and then we're going to have a look at some examples of how we now use this formula. Alrighty. Okay, so let's have a look at this first example. How much space I make myself. I'm going to read it first, and then we're going to go through again and kind of take out the important information that we need. So Thomas starts saving money in the unit trust fund. He immediately deposits 800 Rand into the fund. Thereafter, at the end of each month, he deposits 800 Rand into the fund and continues to do this for 10 years. Interest is at 8% per annum compounded monthly. Calculate the future value of his investments at the end of the 10-year period. Okay, so what I like to do is I like to go back to my formula, and I like to say, what variables can I identify the value of, so that I know what I'm substituting into my formula. So we're going to go back, and we're now going to reread this question and see if we can get the different values into this formula. So he starts saving money. That's great. We don't really care that it's Thomas. We don't really care what type of fund. We just care that he is saving for the future, because he's saving for the future value. Now, this is important. He immediately deposits 800 Rand, right? So that immediately means that whatever my end value is going to be, I need to add an extra 1, because I have that extra 800 Rand that's going to earn interest for an extra period. In this case, an extra monthly period. Because it was immediate, it's an extra payment that we're making. Thereafter, at the end of each month, he deposits his 800 Rand into the fund. So this is the norm. Regular installments of 800 Rand, that is normal. Usually these installments do happen at the end of each month. And so we often put that in there, not to confuse you, but oftentimes the norm is to deposit at the end of the month. And he continues to do this for 10 years. We're going to come back to that in a second. Interest is 8% per annum compounded monthly, and we've been asked to calculate the future value. So we are looking for this F value. which means that I essentially need to find values for x, I, and n. So I sometimes like to do a little checklist for myself so that I know what's happening. I need x, I need I, and I need n. Now, I think quite easily is the I value. This is 8% per annum compounded monthly. Now, remember what this means is that in a year, I need to get 8%. But that 8% is going to be split over 12 months. So what we need to remember is that we need to divide this by 12. Now, I like to write my percentage as a decimal. If you want to, on your calculator, use the percentage button and say over 12, that's fine. Some people, this confuses me, but some people say basically 8 over 100 times 12. And so they write this as 8 over 1,200. This confuses me. Oftentimes, memos write it like this. It means the same thing as everything else. Okay, so as long as you remember it as a percentage, as long as you remember that because it's compounded monthly, you must divide by 12. How you choose to write it is completely up to you. Okay, we then need X and N. So X we know is the regular installment that we're making, and we know that this is 800 Rand. And now the N value we need to be mindful. So this is where we need to consider how many times am I making my payments. Firstly, I'm making it every month for 10 years. So in 10 years, that is 120 months. But I need to remember, like we said up at the start here, I have that immediate deposit. So I need to actually add an extra 1 to this value because immediately I deposited 800 Rand. And so I'm actually going to earn an extra month's worth of interest on that initial 800 Rand that I invested. And so now that we have all of this information, we can substitute into our formula. So 800 times 1 plus I, taking into account the compounding period, to the power of n minus 1 all over I. Okay, so it's not the nicest formula in the world, but you quite literally substitute in, type that into your calculator, and you will get your answer.
Ma'am,
Yes.
by the end, why do we say 120 and not 12? Is it because it's
Okay.
10 years?
Yes.
Oh,
So basically, it's 10 years, and there's 12 months in every year. So we need to say 10 times 12 to give us 120
that's
monthly
the
payments.
one. Okay.
Okay. Right. And then the plus 1 because of that immediate deposit. Right. So, like I say, you chuck that all into your calculator, and we end up. I swear, these children are mine today. I think I have too many cats. I end up with a future value of 148,132 Rand 54 cents. Oh my gosh, and now there's Liverpool happening in the background. This house is chaos at the moment. I'm so sorry. Let me just close my door so that we can't hear that. Absolute chaos. Gosh, I forgot it was preseason matches starting. Sorry, everyone. Okay, so we got our future value. Right. I'm gonna wait there in case you want a screenshot. If you have any questions, let me know. Can't tell you anything about Liverpool or anything else, but anything about finance, I'm your gal. Hopefully, I don't know. Okay. Have we all got our screenshots? Are we all good? Right. And guys, obviously, if at any point you have questions, let me know. This is relatively straightforward. So hopefully there shouldn't be, but you just let me know if you do have questions. Okay, let's look at the next one. Again, I'm going to read it first, and then we will dissect it to figure out what information that we need according to our formula. Caesar decided to start saving money for a period of 8 years, starting on the 31st of December 2009. At the end of January 2010, in 1 month's time, he deposited an amount of 2,300 Rand into the savings plan. Thereafter, he continued making deposits of 2,300 Rand at the end of each month for the planned 8-year period. The interest rate remained fixed at 10% per annum compounded monthly. How much will he have saved at the end of this 8-year plan, which started on the 31st of December 2009? All right, now this is another example where too many words is sometimes a little bit confusing, but we mustn't let it confuse us. So again, go back to your formula and let's see if we can figure out what values we have. You do not have to write the formula each time. I am going to, more so that it becomes super familiar to you and you don't make silly mistakes when copying down the formula. Right, so let's read again. I'm going to come to all of these dates in a second. So since we had started saving money for a period of 8 years, starting on the 31st of December 2009, and at the end of January 2010, in 1 month's time, he deposited an amount of 2,300. That was then the regular deposit that he made at the end of each month. Okay, so this was a monthly installment. It was over an 8-year period, so we must just think about that carefully. And the interest rate was fixed at 10% per annum compounded monthly. Okay, now for me, the dates always confuse me. Like when they gave me a specific date, 31st of December, confused me. Because I was like, well, what does that mean? Am I counting in days? What is the situation? So we're going to go back to what an annuity is. An annuity is regular installments, whatever that period may be, with a consistent amount over time. Okay. As I said, I can't remember. No, obviously I don't. But as I said in the last example, the norm for installments is to pay it at the end of the period. So at the end of the month, at the end of the quarter, whatever the case may be. So if you think about this logically, he started this account on the 31st of December. Okay. At the end of the period, so at the end of the next month, he made his first deposit. So this is actually the norm. He's not doing anything weird. It doesn't say that he immediately deposited on the 31st of December. He just opened the account on the 31st of December. The monthly installments happened at the end of every month as per usual. So it's only if we see that word an immediate deposit or immediate installment, then we have to think about adding an extra month. But in this case, he started the account and then at the end of every consecutive month thereafter, he made his deposit. And this is the norm. Okay, so the dates are kind of there to confuse you, but don't let them confuse you. Read it carefully. Started on the 31st of December and then as per the norm, at the end of each month, made his deposit. There is nothing unusual about it. There is no immediate deposit, nothing I need to stress about. So we just have an 8-year period and every month 2,300 Rand is going into this account. So X, 2,300. I, fairly straightforward, 10%. So 0.1 over 12. Again, you can write it with a percentage over 1,200, whatever you want. This is the way I like to do it, but whatever makes you happy. And the end value is for 8 years, but every single month I'm making a payment. So we must times that by 12. And so that gives me 96 monthly payments. No immediate payments, nothing weird happening. It's just 96. So like I said, the only time we add one is if there is an extra payment. It starts immediately. Then we'll add one. But thereafter, we just leave it normally. Okay. So we actually have everything we need and we can work out how much he will have saved at the end of this 8-year plan he's made for himself. So we substitute in. X is the 2,300, blah, blah, blah. I'm not going to say all the numbers. And then we just type that into our calculator and we get our answer. So in this case, you would have saved 336,216 Rand 47 cents. All right, so very straightforward, nothing tricky here in this case. No immediate payment. It just is what it is, and we can calculate from there. All right, so I'm just going to wait in case we have questions. If you want to screenshot, then we'll have a look at another one. Awesome. Okay. Okay. So it's okay. Let's see. Right. Jessie deposits 400 Rand into an account paying 14% per annum compounded half yearly. 6 months later, she deposits 400 Rand into the account. She then continues to make half yearly deposits of 400 Rand into the account for a period of 9 years from her first deposit of 400. Calculate the value of the savings at the end of the savings period. All right, so again, we're going to read again. We're going to make sure we understand everything. And this one is a little bit different just because of the fact that the period we are working with and the installments is not happening monthly. The installments are still happening regularly. They just aren't happening on a monthly basis, and that's fine. Just as long as they are happening at regular intervals, it is still a future value annuity. Right. Now, importantly, she deposits 400 Rand immediately into the account. Okay, so immediately I need to think, okay, N plus 1. She did it right up front. It then says 6 months later, I'll come back to the 14%. She deposits 400 Rand to the account and continues to do this half yearly. And the deposit amount stayed the same. The interest is 14% per annum compounded half yearly, and the period over which you continue to make these payments is 9 years. And we need to figure out the future value. So let's once again just do our little checklist for ourselves. So 400 Rand is the regular payment. That doesn't change. We're happy with that. 14%, so 0.14, but compounded half yearly. So half yearly is semi-annually, annually. We can say biannually. I'm trying to think how else we can phrase this. Half yearly, biannually, semi-annually. That's kind of it. Half yearly, I must be honest, I hate. I don't know why I hate it, but I hate the phrasing of half annually. I usually use semi-annually or biannually, but basically it means twice a year. Okay, like hemisphere, we don't say hemi-annually, but like semi-bi to twice a year. Okay, so this 14% we're going to have to divide by 2. Again, you can write this as 14% on your calculator over 2, or you can write it as 14 over 200. Whatever you want is up to you. Like I say, the last one confuses me. Don't like the percentage button. I can't tell you why. It works perfectly fine. There's nothing wrong with it. Just don't like it. I prefer the decimal. Okay, I'm a weird person and I embrace it. It's fine. It is what it is. So we sorted out I, and then we have N. Okay, now this is a 9-year period and we're only making deposits half yearly. So for 9 years, we make deposits twice a year. So we get 9 times 2, which is 18. But then once again, we must remember that she deposited 400 Rand immediately. So we need to add 1. The N value I'm therefore working with is 19. Now we can substitute all of this in. So 400 Rand regular semi-annual deposits, 1 plus our 14% compounded half yearly to the power of 19 because of that immediate deposit, minus 1 or 0.14 over 2. Renewal? 1 in this case, because if you have a look right at the start here, it said that she deposits the 400 Rand, and basically that means she's depositing it immediately. And so that 400 Rand is an extra payment that we're making on top of all of the semi-annual payments that we're making at the end of each 6 months. And so because of this immediate deposit, we earn an extra period's worth of interest. And because of that, we have to add 1 to our N value so that we take into account that extra payment that we made. Does that make a bit more sense? Awesome. I know this is confusing, guys, but this is why I'm saying as we practice more and as we go through more, hopefully the language will become more familiar to you. Because I know this is confusing. We have to read very carefully. All right, so once we substituted all of this in, we get that at the end of 9 years with these 400 Rand semi-annual payments, JC will have 14,951 Rand 59 cents. Now this does make sense, right? If she'd been paying 400 Rand monthly, she would have a lot more. But because she's only putting in 400 Rand every 6 months, the amount over a 9-year period seems like a relatively small increase in comparison to where she started. Yeah, so essentially there's two ways we can phrase it. Either we can phrase it like I did in the first question. Let's actually just go back and look at that phrasing, where it says he, she, they immediately deposit. Then that's quite straightforward. That's quite clear cut. We have to add one. Okay, this one isn't so clear cut. But basically, if I'm starting with there was a deposit, straight up deposit, and then continue to deposit, then it's another add one. But here, if we go back to question B, it just said he opened the account. There was nothing about he deposited money into the account when opening it or nothing like that. He just opened it. Thereafter, on the regular end of month interval, we made the regular installments. That's what I was trying to say. So the phrasing is slightly different, and that's what I'm saying. Sometimes this is really tricky because the phrasing is just so slightly different that we need to be aware of what it is. So because there's this mention of this deposit straight up, immediately it happened, and so we must add one. Does that help? I don't know if that helps. Let me know. Okay, cool. And like I said, guys, it does come with practice. These questions don't come up a huge amount, but they can, so it's important. But especially at the end of the year, and especially because, let's be real, a lot of students are writing these exams in their third, fourth, fifth language, okay? We don't try and make it ambiguous. So if we are going to test this concept, usually we will use the word immediate somewhere. And I'm not saying we absolutely will, but the point of the question is not to test, can you apply your comprehension skills? It is to an extent, but we want to see, can you apply the financial maths formulas? So we do try and make it quite clear if there was an immediate deposit by using that phrase. Okay, so we do try and say he makes an, or they make an immediate deposit into the account. All right. Just give me a thumbs up if everyone's happy. Thank you, Sunday. Itabile, Tandiwe, Bufle, Renewe. Thank you, Callan. Asul, thank you. All right, and guys, like I say, Renee, thank you. Kawe, thank you. And like I say, guys, just if it doesn't make sense, ask. All right, because then I can try and explain it better or find an example, whatever the case may be, just because it is very much language dependent. And I struggle with these questions sometimes. If I don't read it properly, I struggle. So it's important that we do make sure. All right, let's have a look at question 4. So Alia has just turned 20 years old and hopes to have saved 8 million Rand by the time she reaches the age of 50. She starts to pay equal monthly amounts into a retirement annuity, which pays 18% per annum compounded monthly. Her first payment starts on her 20th birthday and her last payment is made on her 50th birthday. How much will she pay each month? So once again, we're going to read through this slowly. We're going to hopefully make sure we understand what's happening. And this is, again, this is what you can expect in like a textbook or a test, but again, I don't think we would be, actually, this is something we would give in finals as well, but we're going to read through it to make sure we understand. All right, again, I'm just rewriting the formula. It's going to be what you dream about tonight. So Alia has just turned 20. Okay, I'm not going to, actually, let's highlight that in a different color. Just turned 20 years old. She wants to have saved 8 million by the time she reaches the age of 50. Okay, so we'll get to that now. She starts to pay equal monthly amount, so it's definitely an annuity, which pays 18% per annum compounded monthly. Her first payment starts on her 20th birthday. Okay, so I've made mistakes in my highlighting. Probably no one else cares about this but me, but let's just do this. Okay, I'm gonna say that again. Her first payment starts on her 20th birthday. She has just turned 20. So she's just turned 20 and she is paying into their account, which means that there is an immediate payment. So we have to have n plus 1. She's just turned 20, she's just out of the account, and she has just made her first deposit because it's on her 20th birthday. And so we now need to remember there is an n plus 1 situation. The last payment is made on her 50th birthday, and that kind of makes sense because now it's equal monthly payments until her 50th birthday. How much will she pay each month? Okay, so let's do our checklist. X, that's what we're looking for. So in this case, I'm actually giving you the future value of 8 million rand. Our interest, straightforward, 18% compounded monthly. And now we have to be careful with N. So first question, from 20 years old to 50 years old, that's 30 years. I'm making monthly payments, so I say 30 times 12, which is 360. But because she made a deposit as she turned 20, as she opened this account, we need to add 1. So the N value we're working with here is actually 361 because she made that immediate deposit as she paid 20 and opened the account. And so now we can actually go and solve for our X value. Right, before I carry on, does that make sense to everyone? All this information that we have, is everyone happy with what we're going to do now? Guys, like I say, the more you practice these, and I know we say this all the time, the more you practice it, the more comfortable you will get with the examiner's language. It usually is the same examiner and same set of exam. Oh, I just bit my tongue. Same set of examiners that set the papers each year. So the language doesn't change hugely, and obviously there's moderators upon moderators upon moderators. And remember, our goal is never to trick you. Okay, I know sometimes it feels like we are, but that's not our purpose. That's not our goal in setting the exams. Right, so now we're going to substitute in. So a little bit different this time in that we know the future value. I don't know what sort of 8 that was. My primary school teacher would kill me. Right, we know the future value is 8 million. We're looking for X. Substituting everything else in, interest rate, 18% compounded monthly, to the power of 361 minus 1, all over I. Okay, now I'm going to do this step by step to start off with, but I'm going to show you how you can quite literally now go straight to your answer in a second. And this is just from the inverse operations. I think what most people would do, and again, I'm making an assumption, so you can tell me if I'm wrong, but most people would likely go and say, okay, let's get rid of the denominator. So we're going to times by the 0,18 times the 18 over 12. And we're going to do that on both sides. Now, there is nothing wrong with that. That is absolutely fine. You get rid of the fraction and you end up with 120,000 is equal to X times that bracket. Right, because it's X times the bracket, our next inverse operation would be to just divide by the bracket. That gets rid of it on the right. We obviously need to do the same thing on the left. And that gives you an X value of 558 Rand 41 cents. if you want to actually go and work out the numerical value of the fraction, of the brackets of the fraction, and then work with decimals, it's okay. All right. I don't like working with decimals, so I choose not to do that. But just remember, you should only be rounding off in your final answer. So if you are going to work out the decimal values of the bracket and of the fraction, you need to be working with 5, 6 decimals, because we should only round off our final answer. All right, but we can just make our lives 10 times easier than this. So I'm just going to write this over here just so that we can see. And I'm basically going back to the first step where we substituted it. What I want you to realize is that this is basically x times this entire fraction. So what we can actually do is take this whole fraction and divide both sides by it. So if I say 8 million divided by that whole thing, I'm going to get straight to the answer. Now, obviously, if that makes you a little bit uncomfortable, don't do that. Do it in steps like I've done here. But it is important to recognize that you can actually just go straight to your answer using your inverse operations. Okay, like I said, if that makes you uncomfortable, don't do it. Rather go step by step and you will get exactly the same answer anyways. But you can actually, because it is x times that whole fraction, we can actually just divide both sides by that whole fraction that I've put in a yellow block. But if that makes you a little bit uneasy, leave it, don't do it. Use your normal inverse operations as per usual. Okay, so when we are solving for an x value, can you see my cat in the background? She's so upset that I've closed the door on her. Look at her eyes staring me down. Sorry, I got distracted. I don't know what I was saying now. God, I distracted myself. Oh, so when we're solving for x, really nothing tricky. Like I said, if you don't feel comfortable with the inverse operation all in one go, leave it. Don't do it. Go step by step, because this is an easy question to answer, but you don't want to get yourself turned around with all the horrible fractions and exponents and decimals and all of that. Rather go step by step and make sure we're getting that right. Okay, so I'm just going to wait there for you to screenshot. If you have any questions, please ask. And then I've got 2 that you're going to try by yourselves. I don't know if I'm going to get both on the screen, but we'll see how we go. Isn't this easier? Sunday, I just now have to look at the formula and understand what's happening. X is equal to yes, that's absolutely fine. Sorry, it took me a second. So P being the 8 million times the interest over the fraction. That is absolutely fine if you want to work with that formula. Absolutely. It's basically the same thing, except you've manipulated the formula earlier, which actually probably is easier to work with in terms of your substitution. Perfect. Okay, just give me a thumbs up if we have what we need. Lovely. Okay. Right. Oh, I am going to click both. Lovely. Let's move this up so we can actually click both. All right, so there are 2 questions I would like you to try. I will make it a bit bigger so that you can see. 2 questions. You've got 5 minutes left. I'll give you all 5 minutes and then I'll show you the answers and then you can see, and then that's it. Like I said, we will get into loans and future balance, outstanding balance, etc., on Wednesday, which is definitely the trickier side of grade 12 finance, but we will deal with that on Wednesday and you don't need to stress about it. But let's try these 2, see what we get, and then we'll have a look in a second. Remember, you are welcome to put your answers in the chat for me to have a look at, for you to help everyone else. Okay, I see some thumbs up that we are done. I'm just going to wait 1 more minute just for you to finish it up. Okay, nice, very well, well done. All right, so let's have a look at the first one. So a monthly deposit of 800 Rand into a savings account is made if the annual interest rate is 12.5% compounded monthly and an immediate payment of 800 Rand is made. How much is in the account after 6 years? So substitute in, we just need to remember that instead of 72 payments, it's 73 because of the immediate payment. And we get 86,843 Rand, 14 cents. Relatively straightforward. Sorry about my handwriting there, it was a bit dodgy, but it's fine. Okay, and then the second one, Megan wants to save R1 million by her 30th birthday. On her 18th birthday, she opens a savings account for this goal. She makes equal monthly payments into the account starting 1 month after the account is opened. So remember, this is the norm. She's opened the account, there is no immediate payment, just makes monthly deposits. Last payment is made on her 30th birthday, all normal. The account pays interest at 15% per annum compounded monthly. How much will she have to save each month to reach her goal by her 30th birthday? So if she starts on the 18th and she gets to her 30th, that's 12 years. Okay, so we just need to bear that in mind. Now you can draw a timeline if you want. This is more just to show you if you wanted to. I don't find timelines particularly useful for future value, but if you wanted to, you could. I don't see the point of them, but whatever. We've got R1 million. was looking for X. There's the 15% per month, 144 months, because like I said, it's 12 years, and because it's not an immediate payment, it's not adding one, it's just normal. Like Sunday said, if you wanted to, you could manipulate your formula to do it exactly like that. So your future value times the interest over that whole bracket. That's absolutely fine. But regardless of how you do it, you get that the monthly installments was 2,508 Rand 77 cents. Okay, so those two, I would say, in terms of immediate payments and in terms of solving for X, are definitely the more complex of your future value questions. And so it is important that we do know how to do that. I'm just going to try and get it all onto one page. There we go. So you can screenshot just so that you have the answers. And then, like I say, on Wednesday, we will look at present value annuities. So this is working with loans. And this is where we talk about balances outstanding. What do we still owe on the loan after a certain amount of time, not necessarily at the end of the loan or whatever the case may be, and looking at those types of questions. Okay. So once you have your screenshots, you are welcome to leave. That's absolutely fine. I will see you guys on Wednesday. Please make sure your term marks go up onto Google Classroom. And I will see you then. Have a lovely Tuesday, Wednesday, and I will see you on Wednesday evening. If you have any questions, obviously, please ask, but otherwise, have a good evening.
You know what I realized, ma'am?
Yeah.
When I just used the fraction 0.15 over 12, instead of giving me 12,500, it gives me 8 million. So I realized that I had to convert this fraction into its decimal first to get the 12,500, which is really scary.
That's what did you do initially?
So what I did, it was
This would work either way.
the top part, and then it was 0.15 over 12. Then I
Yeah.
multiplied with a million.
Okay.
And that gave me 80 million. That's what it gave me.
Okay.
And that's wrong. It's supposed to be 12,500. So I had to first convert what 0.15 over 12 is, and then times that, which was 0.0125 with a million, which gave me 12,500.
That's very weird because it should give you exactly the same answer.
Exactly. That's what I was wondering.
1 million times the 0.15 over 12. Yeah, 12.
Yep.
That is weird, Boucle.
It's a
Tell
sign.
me exactly what you're typing in.
It's a sign.
No, I'm concerned about this. Tell me exactly what you've just typed into your calculator to get this 8 million.
All right, let's see. 0.15 over 12. Oh, I see what I did.
Okay, what did you do?
Instead of multiplying,
You
I
divided.
divided.
Yeah. So remember to multiply. Okay.
But I got it right now.
Okay, good. Good. I was very concerned. I was like, the math ain't mathing when the math should be mathing.
All right.
Okay, good.
Thank you, ma'am.